And welcome to this presentation all around the AOS-CX 10.12 release, specifically as part of the 0006 update. And this topic is NAT with the Pensando PSM and the CX10000. My name is Steve Bartlett, Technical Marketing Engineer supporting CX switching. And the agenda for just 4 topics to cover: an overview of NAT at the very beginning, followed by some details on how the features are implemented on the CX10000, the PSM, followed by a configuration example, and we'll just finish up on some scalability. Let's jump straight into the overview. NAT, Network Address Translation. I'm sure most of us are familiar with this, but just a quick run through of some of the themes that it covers. So a network address translation, a method of mapping an IP address space into another IP address space by modifying the network address information in the IP header while the packets are in flight as they traverse a layer 3 routing device. So it can apply to the source IP, the destination IP, and the destination port, and a combination of all 3. So typically used to map private addressing going out to the internet into a public IP address space, or used in private organizations where there are overlapping IPv4 addressing within that organization. So types of NAT: static NAT, this would be a one-to-one translation of the source and or the destination IP or ports, or a combination of all. Dynamic NAT, where you've got many-to-many address pools are used for untranslated IPs to translated IPs. And PAT, port address translation. So this is many-to-one and sometimes called NAT overload. So this is used when we've got multiple private IP addresses translated into one public IP address. So warming to the NAT overview use cases, and there are of course many variations of this theme I'm about to describe. So peering to the internet to translate from one private IP address or block to public addressing, or peering into the same organization or into the cloud provider's network across the WAN, or to overcome overlapping or conflicting IP addressing. And we can do this with DNAT and SNAT. And in this example, we've got a DC, CX10000, a border peering to the WAN. So for DNAT, destination IP NAT, is where the destination NAT is translated and typically used for inbound ingress traffic from the WAN into the DC in this example. So in this example, we've got destination NAT IP, or the originating destination IP of 1.10.100.95, now translated to a destination IP of 192.168.1.10. So that will be DNAT, destination NAT. And of course there's source NAT. Source IP is translated, typically used for outbound traffic from the DC to the WAN in this example. So in this example, we've got 192.168.1.11 as the source IP, goes through the NAT engine on the 10K, and it's translated to 1.10.100.96 as it egresses into the WAN. And another overview using NAT, a use case combining with the firewall and IPsec functionality all in the same appliance. And this is where it becomes very flexible and very, very powerful potentially. So we can have all these features and functions: NAT, firewall, IPsec services on the border leaf here. Multiple options of how to use this, providing a lot of flexibility with IPsec and the firewall engine. So with this combined feature function, NAT, firewall and IPsec services, we can have employees, for instance, with IPsec software can access internal websites that are both being NATed as well from outside to in, and have the firewall inspected. And DC internal subnets can be hidden from outside the DC as well. And then there's the potential reduction in appliances with separate firewall, NAT and IPsec devices, providing that complexity with service training. So with using the CX10K with these features of firewall, NAT and IPsec can simplify network architecture and operations. So on that theme, the CX10000 using as a border leaf could replace physical and virtual appliances, allowing multi-tenant encrypted connections with IPsec VPNs, encrypted tunnels, all providing 800 gig layer 4 stateful firewall capacity within a VSX pair and inline NAT for all traffic ingressing and egressing the DC. Now let's take a look at some of the details on how NAT is used with the CX10K and the Pensando PSM. So let's take a look at the CX10000 policy flow direction. So from inside the DC going out on egress to outside of the DC to the WAN, for example, then we have the firewall inspection followed by the NAT policy application, and then we have onto the IPsec encryption if it's required, and then out of the DC, coming from outside the DC into the inside of the DC, it's reversed. We've got the IPsec decryption followed by the firewall inspection, and lastly at the very end we then have the NAT inspection. That's the flow coming in. Now there's a few things to note. So the interfaces facing inside the DC need to be configured for persona access, and on the outside of the DC facing interfaces they need to be configured for persona uplink. Now the IPsec encrypt policy and the firewall policies do not need to be applied, but you do need to redirect the traffic to the DSM modules to have the NAT policies applied should you need them. So let's take a look at the NAT services in more detail. So NAT services are supported on incoming connections, that's traffic entering the data center, with an ingress NAT policy, and for outbound connections, that's traffic leaving the data center, with an egress NAT policy. So the ingress NAT policy, all traffic entering the data center are subject to an ingress NAT policy evaluation on the assumption that a NAT policy is applied. And the upstream external facing ports require, as I mentioned earlier, the persona uplink profile. Only SVI uplinks are supported. Layer 3 routed interface ports and Layer 3 interfaces are not supported. On egress, the egress NAT policy, so this is all traffic leaving the data center, are subject to the egress NAT policy evaluation if that egress policy is applied. Internal facing ports require the persona access profile, and only SVI links are supported. Again, Layer 3 routed interface ports and Layer 3 sub interfaces are not supported. And in both directions, firewall policy, should it be applied, is applied first if it's configured. So let's take a look at the supported operations in this initial release. Now do remember this is the initial release and this feature will be enhanced over the months moving forward. So remember this is the initial release, so we're just looking at the things that are supported and the things that highlights of the things that are not supported. So static one-to-one NAT is supported. One-to-many or many-to-one mapping is not supported in this initial release. Likewise, dynamic NAT or many-to-one NAT PAT is not supported in this initial release. Source NAT on ingress and egress policy is supported, and destination NAT on ingress and egress policy is supported as well. And just to remind you, all configurations are implemented on the Pensando PSM. NAT switch profile. So the use of NAT requires the DSS, that is the distributed services switch, the 10K, to be in border leaf mode. So this means that you need to configure the switch profile from its default to layer 3-core. So from the config editor, profile, layer 3-core, obviously save your configuration, and then show profile current after a reboot. And it should come up layer 3 core. On the switch side of the interfaces, these need to be configured as persona access, as in the example here. And the external facing interfaces, they're the interfaces facing outside of the DC fabric, are to be configured as persona uplink. So I need to mention a little bit about NAT iFlow and rFlow. This behavior is consistent across all rules policy engines in the CX10K. So there is no need to create a NAT policy rule for the rFlow. This is the responder flow. The rFlow is implicitly installed when you create the iFlow rule. So in the below example, which I'm about to bring up now, the source NAT rule changes the source IP address of the iFlow source. The rFlow will implicitly be NATed to the destination IP address. So let's talk this through. So we've got a client host of 10.10.200.200. This is the original IP address. Now this is a source NAT rule. Doesn't have to be a source NAT rule, but it is in this example. The source IP is translated to 172.16.200.200. Destination IP does not change, and that is outbound. That's the iFlow, and the rule is required for this. The return flow, the responder flow, there's no rule required. So the original IP from the client host over here, 10.10.201.201, is targeting 172.16.200.200 because that is now the translated source IP address of the flow that's gone out, and the rFlow will have that destination IP translated dynamically back to 10.10.200.200, which is the originating client source address. So let's take a look at source NAT. So source NAT is a term that refers to the source IPv4 address of the iFlow, the initiator flow of the packet that is translated. The rFlow is the return or the responder flow of the destination IPv4 address, and this is implicitly translated by the distributed services switch. That's the CX10000. A NAT rule can be defined as one-to-one mapping for a given address, a prefix subnet range, or a given IP collection list of IPs. So the NAT egress policy, as an example, here we've got a host 10.10.200.200. That's its original IP, and that is translated to 172.16.200.200. And the destination IP does not change in this example to 10.10.201.201, and that's the iFlow. The responder flow from this client host is now targeting 172.16.200.200, this destination IP, and that it will be the rFlow, and that IP will be then translated back to the original client host address as part of this egress source NAT policy. Likewise, for an ingress policy and source NAT, exactly the same process occurs. So we have client host 10.10.201.201 translated to its source address to 172.16.201.201, targeting its destination IP of 10.10.200.200. Client host 10.10.200.200 targets the destination address of this host of 172.16.201.201, and that will be the rFlow, which is dynamically translated as part of this source NAT policy. Destination NAT operates in a similar convention as source NAT. So within the context of the PSM and the CX10000, the term destination NAT refers to when either only the destination IPv4 address of the iFlow packet is translated, or when the destination IPv4 address and the destination port of the iFlow are translated. Again, for the rFlow, the responder flow, the source IPv4 address or source IPv4 address and port combination is implicitly translated by the distributed service switch. A NAT rule can be defined again as a one-to-one mapping for a given IP address, a prefix subnet range, or a collection of IPs. And destination NAT can be used with or without the port translation, which is optional. Again, the same approach for an egress NAT policy and the ingress NAT policy, whereby the iFlow originating destination IP can be translated optionally with the translation with the port, and the rFlow, the responder flow, dynamically trans the source IP and the port combination, if it's as part of the translation rule, back to the originating destination IP and port combinations. So again, a single rule in the NAT policy is there to support this. So on to twice NAT now. So twice NAT refers to the scenario where either the source IPv4 address and the destination IPv4 address of the iFlow get translated at the same time. So if we take this example here, we've got the host 10.10.200.200 source IP, the originating destination IP 10.10.201.201, and that gets translated to a prefix of 172.16.200.200 for the source IP, and the destination IP gets translated to 172.16.201.201, and also the originating destination port in this example has been translated from 2002 to 2020. And the rFlow, the responder flow, the source IPv4, destination IPv4 source port, if they're translated, if applicable, is NATed implicitly by the DSM for the rFlow. Again, a one-to-one mapping for a host, a prefix subnet, range, or a given collection of a list of IPs. So creating a NAT policy is very, very easy and very similar to creating a firewall policy and the firewall policy rules. So to start off with, under tenants, you navigate to NAT policies in the user interface, and there you can create a policy with rules. So this is a rule that I've got displayed here, and what it's going to do is effectively NAT translate on the source IP address. So the original IP address is 10.10.200.200. Destination IP address it's targeting is 10.10.201.201. If we move to the right here, this is where the translation NAT rule options are. So I'm translating the source address, and it's going to be translated to 172.16.200.200. If I wanted to do a destination translation address, I would highlight that radio button here. Once you're happy with the rule, and effectively you just save it, and there you have your source NAT egress rule created. And once we've created that rule, this is what it would look like in the policy. Source address 10.10.200.200. Destination address 10.10.201.201 doesn't change, but the translated source address is 172.16.200.200. And now let's take a look at an example where we may need a destination NAT ingress rule. So if we take a look at this example, so if we looked at this previous rule that I made, which was from client host 10.10.200.200, and the iFlow was going out, so translating source address 10.10.200.200 to 117.16.200.200. The iFlow going out, obviously, if that was the only connection that was required, then that would be fine. But when you've got an instance where client host 10.10.201.201 has to initiate a session to 10.10.200.200, which is having its source address translated to 172.16.200.200, we have to create another rule. So this is for the iFlow coming in. And what that would look like is, what is relatively simple, is the destination address here is 172.16.200.200. And the translated address for the iFlow coming in on ingress is 10.10.200.200, which is the original client host. And this will be applied as an ingress policy for this iFlow session to support bidirectional iFlow connections from both clients. So this is what the destination ingress rule would look like. We've got a destination address of 172.16.200.200 from outside the DC, and that destination address is for any client targeting that destination address will then get translated back to 10.10.200.200, which is the original IP address of the host. And the next step is to apply the NAT policies, because there's two of them, to the appropriate VRF. So the VRF, from the VRF menu, edit this particular VRF, which is IPsec-services, and then apply the appropriate NAT policies. So there is an ingress NAT policy, and I've called it the DC1 destination NAT policy, and the egress NAT policy is DC1-source-NAT. So there's two policies assigned, NAT policies to assign to that specific VRF, and of course you just save them and they will be applied. A summary then of the NAT policies. So there was two policies, one for a source egress rule and one for a destination ingress rule. And if you navigated to the PSM under tenants, under NAT policies, they would look like this. Policy name, first of all, is the DC1-source-NAT, and the distribution targets that I were using, there's two switches in the policy distribution target DC1-IPsec, and the associated VRF is IPsec-services. Likewise, for the ingress rule, the DC1-destination-NAT for the policy name. Again, same policy distribution target, DC1 IPsec. Again, same VRF, IPsec-services. And they were comprising of these two rules. So let's take for the source NAT egress rule, which is DC1-source-NAT. So client host 10.10.200.200 is a source original IP address that will be translated to 172.16.200.200. Destination IP is 10.10.201.201, which doesn't change. That's on the iFlow going out, and as I mentioned earlier, that would be fine if there was no iFlow coming in from that host. So if you did have an iFlow initiated flow coming in from outside the DC into this particular host, you need an ingress policy with an ingress rule, and this would be taking client host, the source address 10.10.201.201. Anything actually targeting on the rule was 172.16.200.200 would be translated back to 10.10.200.200. And there we've got, once we've done those two rules, we effectively are supporting a source NAT going out with an iFlow, and also an iFlow coming in targeting the translated IP address of our original host. And on to scalability. Just be aware that the scalability of the feature and functionality across the Pensando PSM will vary depending on whether you're using a 3-node cluster or a 1-node cluster fabric scale. So this is no exception on that. So the policies for a PSM single node cluster is 64 compared to the policies on a 3-node cluster, which is 256. Everything else though is identical between the 3-node and the 1-node. And that brings us to the end of the presentation, and I do thank you for tuning in.